Let's look at one final example of the application of differentiation on exponentials and applying the quotient rule. So again, we start with u and v, where u equals e to the x, and we know that the derivative of e to the x is e to the x, and v is our denominator, which is 1 minus x squared, and when we differentiate that, we end up with v dash equals negative 2x. Now, substituting this into our quotient rule, u dash v minus v dash u all over v squared, we end up with e to the x times v. Let's keep this in brackets because it's a binomial, minus v dash, which is negative 2x, times u, which is e to the x, all over v squared, which is 1 minus x squared, and we're going to keep that in its factored form. Okay, let's again see if we can take out a common factor as we have previously in our examples, and you can see that we've got this e to the x as a common factor of both terms, so we'll take that out, and then we've got 1 minus x squared, and then minus negative 2x becomes plus 2x all over our denominator 1 minus x squared. Now hopefully you can see that what we've got in here is a trinomial, and what we need to do is actually solve this trinomial equals 0. So we're going to solve y dash equals 0, and in doing so we're going to solve 1 minus x squared plus 2x is equal to 0. Now remember, the reason why we're just focusing on this part of our derivative is there is no solution for when this will equal 0 e to the x. Think about the graph of an exponential function, and we can't have a 0 denominator because that would give us an undefined result. So we're going to focus on this trinomial in here and solve that equal to 0. I know many of you like working with positive x squared, so let's rearrange this. So we end up with this result. So x squared minus 2x minus 1 equals 0. And our first default will be to see if we can factorize. Are there any two numbers that multiply together to give us negative 1, that add together to give us negative 2? And if not, then we need to go to our quadratic formula, which is x equals minus b, which in this case, negative b is 2, so that's going to give us positive 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, all over 2. Now we end up with 2 plus or minus the square root of 4, and then negative 4 times negative 1 is positive 4, so it becomes plus 4 all over 2. So we end up with 2 plus or minus the square root of 8 all over 2, and we can simplify that by taking out a common factor of 2, because let's think about root 8. Root 8 is actually root 4 times root 2, okay? And root 4 is 2 root 2. So now that gives us 2 plus or minus 2 root 2 over 2. Taking out our common factor on the top and the bottom, we've got 2, 1 plus root 2 on 2. The 2's cancel, so our final solution is just 1 plus root 2. Now keep in mind, we plus or minus root 2, plus or minus root 2. Keep in mind, we now need to find what the corresponding y value is, and I need another ball.